Now let's move to question 3. So for this question asks us about the yield, the final yield. So a chemist is making a species that requires 4 steps. The first step gives a 66% yield. Second step gives a 50% yield, while the third step gives 25% yield, and the fourth step gives a 40% yield. So the question asks us about the overall percentage yield for this synthesis, and the question asks us also to suggest how to improve the overall yield of the process. So first thing first, I made this kind of diagram so we can see the ratio between step 1 until step 4. So for step 1 we have 60%, and later on we move to 50% and 95%, and the last step is 45%. So to find the overall percentage yield, so what we need to do is we need to the times from the first step and fourth step. So we have so I convert 60% into the decimal point, so we have a 0.66. And for step 2 we have 0.5, step 3 we have 0.95, and step 4 we have 0.4. So we time all together and then give us a 0.1245, and if you convert to percentage it will be 12.4. So it will be 12.5%, and the question asks us to improve the overall. So you need to improve, so we need to find the least number, which is the smallest number. So the smallest number here is this one. So that's why we can say that at least to improve the overall percentage, we need to improve this step 4. So if the recovery we can get more than 40%, so this step we improve. Besides, we also can suggest that step 2 also need to be improvised. So if we can improvise this both two steps, so we can get the final yield will be increased. So if the question asks us about how to prove your answer, so what you do is you just put any number here. Maybe you can put here, maybe you can put 0.7 for example. Here you put a 0.6 for example. You plug in the number and then you can see the percentage will be increased. Question 4. So for this question, question 4 asks us about the reaction of esterification reaction. So we have ethanol. We have a methanol, and also we have ethanoic acid. So the question, the reaction combined the following version based on their molar mass. 30 gram of CH3OH, this one is methanol, reacts with 60 gram of ethanoic acid. To form 54 gram of the ester product in a particular reaction, 1.8 gram of methanol is mixed with an excess of ethanoic acid. So this one is excess, so use the keyword here. So when we have excess, we know that the other one is limited reactant. At the end of the experiment, 2.6 gram of the ester is extracted. What is the percentage yield? So given the percentage yield of the formula, so what we need to do is first what we need to do is we need to calculate the theoretical maximum yield. So we know that 30 gram of methanol will form 64 gram of the ester. 30 gram of methanol, 1 mole of methanol react with 1 mole of ethanoic acid. We have this ester. So in the proportion of 1, so 1, 1, 1. So here if we convert it, I believe you will get this 1 more, and then this one is also 1 more. If we convert it to mole, trust me, if you can create by your own if you are have more time to create it. So now what we do is we know that the gram of methanol, sorry, we know that the gram of methanol will form 64 gram of the ester. How about if we have 1.8 gram of methanol? How many ester that we produce? So thus we know that if you're using this relation, 32 over 1.8 equal to 74 over 8 over x, and then if we calculate it, we rearrange it, we will have x equal to 74 times 1.8 over 32. So we will get 4.2 gram of the ester product. So this one is the theoretical yield. So this one is theoretical yield. So what is theoretical? Theoretically, if we have 1.8 gram of methanol, we will get 4.2 gram of ester. However, the question just mention this: at the end of the experiment, 2.6 gram of the ester is extracted. So the actual yield is not same with the theoretical yield. So that's why we need to find the percentage yield. So the percentage yield is given by the equation, actual yield. So we have this actual yield. So our theoretical yield is 4.2. So that's why 2.6 divided by 4.2 times 100%. That's why we have 62% of the yield. The yield is 62%. So this is how this is how we answer this kind of question, and you need to know the relation of what is the x-size, what is the limited reactance. So this kind of knowledge you need to know. So in order for you to answer this question, so let question 5. So question 5 mentioned about a chemist prepares a solution containing 1/50 mole of propanol in 1000 milliliter of water. How many moles are there in a 250 ml liquid of the solution? So it means that this one is a ratio. So we know that if you are not sure what is 1/50, I advise you to convert it to mole. So 1/50 mole equal to 0.02 mole. So thus we can have the relation. So as mole in 250 ml of solution, and this solution we have this kind of solution 0.02 mole in 1000 mole of solution. So by using this relation, so we can have this relation. So by rearranging our equation, so we will get, that's why we add small, the mole present in 250 milliliter of liquid, 7 milliliter of water is 0.005 mole. So you also can rewrite the answer like this. So it depends on only 5 times 10 power of negative 3. Next, the question asks about the hydrogenation of acetylene to form ethane in situation is below. So the hydrogenation of acetylene to form ethane. So now we have acetylene, we have hydrogen, and we will form ethane. So the question give us this kind of information. Suppose 20 kilomole per hour of C2H2 or acetylene and 50 kilomole per hour of hydrogen gas are fed to a reactor. What is the stoichiometric ratio of H2 to C2H2? So stoichiometric ratio. So we know that this one is 2, this one is 1. So it means that if we look at the questions, say that 1 mole of acetylene react with 2 mole of hydrogen gas and will form 1 mole of ethane. So the question asks us about the stoichiometric ratio H2 to C2H2. So that's why we put it to 1. So if you put it like this, so it's still wrong because this one is ethane to hydrogen. Now the question asks us the ratio of H2 hydrogen gas to acetylene to H2. So that's why we put 2 to 1. So and then question asks about what is the ratio of H2 to C2H2 in feet. In feet. This one is documented, this one in feet. Feet is in the rate the actual. So we know that from the question asks us to give description of this one. We have 20 kilomole of acetylene and so 50 kilomole of hydrogen gas. So that's why we put it. What is the ratio of H2 to C2H2? So that's why we put 50 kilomole ratio 20 kilomole. So if we simplify, we get 5 to 2. So this is how we write it. And then question asks about the limiting reactant. Limiting reactant. So here the limiting reactant is, of course, if we see, it should be C2H2. Why? Because the solution ratio is 2 to 1. And the actual ratio is 5 to 2. So now, if we look at this, if we put 2, so it should be 4 right here. So that's why it will become, this one will become our limiting reactant. That's why we can confirm that acetylene is our limiting reactant. And then the last question, what is the chemical that has fractional excess for this reaction and what will be the value? So now the excess chemical here is H2 gas, and the value is 10 kilomole. So that's why, because we have 5. So now if we have 20, so it will react with 40. So now here we have 50. So that's why if we minus it together, we minus 50 by 40, so that's why we get a 10 kilomole. So this is how the relation of this question towards the mathematical concept that we learned before.